information. So hopefully we can get through these notes quickly. We learned last time what parallel lines are. A parallel line are just coplanar lines that don't intersect because they have the same slope. The symbol for parallel are just two upright lines right next to each other. So we can say that line S is parallel to line T without writing it out in words and using the parallel line symbol. Skew lines, which we won't actually talk about a lot in this unit, but it is something that you need to know, are lines that are neither parallel nor intersecting because they're not coplanar. So if we have a plane, like a flat sheet of paper, and we draw a line on that plane, and then we have, let's say, a line, if we think of maybe like an arrow shooting through the paper as if it were a target, those two lines would potentially not cross, but they are also not intersecting. I'm sorry, they're also not parallel because they're not running in the same direction because they're not in the same plane. So those would be skew lines. Okay, so using this diagram over to the right of this cube, we can answer these questions. Name a set of parallel lines. So there are lots of different answers. I picked PQ and line WX, but PQ is also parallel with SR. It's also parallel with line ZY. And you could pick a different line to start. You could start with PS, and then WZ is parallel QR, XY. So you can pick any set of parallel lines that you'd like. Name a set of skew lines. Again, there are a lot of possibilities. I picked line PS and line RY, but you could pick PS and QX, for example, or PS and ZY, PS and WX. Any of those combinations would work. You could pick two totally different lines, QX and WZ, for example. So it's completely up to you, but just make sure that they're not running in the same direction, nor are they intersecting, like WP and PS, for example. Okay, name a set of parallel planes. So again, planes that run in the same direction. So an example would be the top of the box and the bottom of the box. The left side of the box and the right side, the front and the back, all of those are parallel planes. So I picked plane WPZ, which is the left side, being parallel to line QRY, which is the right side of the box. And then name a set of lines skew to WP. Again, you just need to name one set. So I picked SR, but also ZY, QR, or XY would also work. Okay, so a transversal is simply a line that intersects two other lines, and I had a picture here. Somehow disappeared. Um, So any two lines that are intersected, that are both intersected by the same line, would be considered a transversal. Okay, so highlight your transversal, maybe do it in another color or highlight it in with a highlighter or something like that after the fact. But please make sure that you keep in mind that the transversal is the one that's intersecting the other two. Okay, so when we have two lines being cut by a transversal, like we do in each of these situations, we end up creating different angles, 1, 2, 3, 4 here, and 1, 2, 3, 4 angles here. And of those 8 angles that we've now formed from our two lines and our transversal, we have different angle pairs. These angle pairs are super important. So we have alternate interior angles, which comes from the fact that we have two angles that are on opposite sides of the transversal, like my two yellow ones here, or my two green ones, but are inside the intersected lines. So they're inside my two lines, and they're on opposite sides of the transversal, hence alternate and interior. What we need to know about this is if the lines are parallel, alternate interior angles are congruent. This is super important. I cannot stress this enough. We will be using this for the rest of the year. Alternate exterior angles, therefore, are similarly angles that are on opposite sides of the transversal, but outside the intersected lines. And again, if the lines are parallel, then these angles are congruent. We have same side interior angles, which are exactly what they sound like. Angles that are on the same side of the transversal, but inside the intersected lines. And if the lines are parallel, then these angles are supplementary. It's kind of nice because we've got the whole alliteration thing going, same side, supplementary, so it makes it easy to remember. And we have corresponding angles, which are sometimes confused with same side interior angles, but these are angles that are formed by the intersection of the two lines and the transversal, and they're in matching positions. And by that, I kind of mean like top left, top right, bottom left, or bottom right. So this angle up here is in the top left of these four angles. So the corresponding angle to it down here would also be in the top left position, and so on and so forth. If the lines are parallel, then the corresponding angles are also congruent. So alternate interior, alternate exterior, and corresponding angles are congruent if the lines are parallel, and same side angles are supplementary. So the difference between the same side interior angles and the corresponding angles is that same side interior are both contained within the two lines, whereas corresponding angles are in the same position, so one will be inside and one will be outside, for example. Okay, in example 2, we're going to use the diagram to identify different angle pairs. So corresponding angles, there are lots of angles to choose from. I chose angle 1 and angle 5, but 2 and 6 would work, 3 and 7, 4 and 8, 9 and 13, 11 and 15, 10 and 14, or 12 and 16. A pair of alternate interior angles, you could use 3 and 6, 11 and 14, 12 and 13, 4 and 5. You could use 8 and 13. You could use 4 and 9, 2 and 11, or 6 and 15. Lots of different choices there. Same side interior angles, I chose 4 and 6. You could also choose 11 and 13. You could choose 4 and 11, or you could choose 6 and 13. Let's see. A pair of alternate exterior angles, again, I chose angle 1 and angle 8. 2 and 7 would also work. 9 and 16 would work. 10 and 15 would work. 7 and 14 would work. 5 and 16 would work. 3 and 10 would work. And 1 and 12 would also work. And finally, name the transversal that forms angle 2 and angle 6. So this throws people off a lot. Here's angle 2, and here's angle 6. Okay, so both of these angles are formed by one single transversal, and the line that they have in common is they both have line T. So that would be our transversal, and line L and M are our two intersected lines. All right, so proofs, everyone's favorite. These are pretty easy. We're proving the alternate interior angle theorem is true, that when lines are parallel, alternate interior angles are congruent. So we always start with our given, A is parallel to B. If A is parallel to B, then we know that angle 1 and angle 2 are congruent because corresponding angles are congruent. We also know that angle 2 is congruent to angle 3 because of vertical angles. So, by that logic, angle 1 must be congruent to angle 3 because of the transitive property of congruence. You could also use the substitution property here. Either one would work. In example 4, we're proving the same side interior angles theorem. So we have A being parallel to B, that's given. And so if that's true, then angle 3 and angle 2 must add up to equal 180 because of the angle addition postulate. I would also accept the definition of a linear pair. So angle 1 is congruent to angle 3 because if the lines are parallel, then corresponding angles are congruent. And so the measure of angle 1 plus the measure of angle 2 would also equal 180 because of substitution. And angle 1 and angle 2 are supplementary because of the definition of supplementary angles. If two angles have a measurement that add up to equal 180, they must be supplementary. Okay, so this is kind of neat. If we know that our two lines that are being intersected are parallel, then all we need is one angle measurement to know every single other angle. So let's take a look how. So if this angle given to us is 30, then angle 1 has to be 150 because they're supplementary. They form a linear pair. And angle 2 must be 150 because it's vertical to angle 1. And angle 3 must be 30 because either it's vertical to our 30-degree angle or it's a linear pair with angle 2 and also with angle 1. So we could find it by subtracting from 180. Angle 5 must be equal to 30 because 30 and the 30-degree angle and angle 5 are corresponding, so they're congruent. Angle 6 is vertical to angle 5, so it's also 30 degrees. And angle 7 is equal to 150 because it is a linear pair with angle 5, it's a linear pair with angle 6, and it's corresponding to angle 2, so it would have to be congruent to angle 2. And if you see that, if you notice, we get kind of this checkerboard pattern where we have all of our congruent angles being kind of opposite to one another, and kind of get like this opposite picture. So whenever whenever two lines are parallel and cut by a transversal, we can find out the measurement of all of the angles simply by knowing one. Okay, so how would you find that angle 2 is, or the measurement of angle 2 in two different ways? If we know that the measurement of angle 8 is 48, we kind of talked about this. Our two lines are marked as being parallel. So we could say that angle 2 must be, 180 minus 48 for a couple of different reasons. We could say angle 8 and angle 6 are a linear pair and therefore supplementary. And angle 6 and angle 2 are corresponding, so they must be congruent. So finding angle 6 would help you find angle 2. Additionally, you could say angle 4 and angle 8 are corresponding, so they must be congruent, and then 4 creates a linear pair with angle 2, so their measurements would be supplementary. Okay, real world problem, we have two workers are painting lines for angled parking spaces. The measurement of angle 1 is 60 degrees, and they paint a line so that the measurement of angle 2 is also 60 degrees. Explain why their lines are parallel. Well, angle 1 and angle 2 are alternate exterior angles, and we know that for those to be congruent, the lines had to have been parallel, because if the lines are parallel, then the alternate interior angles are congruent. And then finally, we're going to use the information to do some problem solving. So here we have alternate interior angles, and they tell us that L and M are parallel. So we know that these two angles are congruent, so all we have to do is set them equal to each other. In this case, it's a little bit more complex. We have parallel lines here, and they're being cut by two different transversals, this one right here and this one. If we look carefully, 27 is actually not an angle that the 27x is not an angle we're going to be concerned with because it's actually not formed by our parallel lines and our transversal. It's formed by our two transversals. So that's extra information designed to kind of muddy up the problem to make it a little bit more difficult. But if we compare our other two angles, these angles are not alternate interior, they're not alternate exterior, they're not corresponding, they're not same side interior. But if we keep in mind that these two angles are vertical and therefore have the same measurement, we could say that this angle right here is also 19x, which tells us that these two angles are same side interior or supplementary. So if I add them up and set them equal to 180, I can solve for x. And finally, in letter C, we have two corresponding angles. Corresponding angles are congruent when the lines are parallel. So we set them equal to each other. And here we have same side interior angles, which are supplementary. So we add them up and set them equal to 180. That's all she wrote. I'll see you guys in class on Wednesday.